In 1911, a machinist named William Chen stood at a lathe in a Cleveland machine shop. The sound of metal cutting metal filled the air. William was turning a steel shaft for a locomotive axle. The shaft was 6 feet long and 8 inches in diameter. It spun in the lathe at 300 revolutions per minute. William had been a machinist for 15 years. He knew this machine. He had turned thousands of shafts. He leaned forward to check the surface finish. His sleeve was loose. Factory rules required tight sleeves, but the shop was hot and William had rolled his cuffs up an hour ago. The fabric brushed the spinning shaft. The shaft grabbed. The sleeve wound around the steel in one complete rotation. William's arm followed. In 2 seconds, his arm had wrapped around the shaft 4 times. In 3 seconds, his shoulder dislocated as his body was pulled into the machine. In 4 seconds, his ribs broke as he was pressed against the lathe bed. The lathe did not have an emergency stop. The motor was in the basement, controlled by a lever 30 feet away. The shaft kept spinning at that speed. When someone finally reached the motor control, William had been wrapped around the spinning shaft for 45 seconds. What came off the lathe was no longer recognizable as a human body. This is not a story about one lathe. This is a story about the machine that treated machinists like thread on a spool. The equipment that spun too fast to escape and too powerful to release. The tool that killed experienced workers more reliably than any other machine in the shop. Before computer-controlled machining and modern safety standards, creating round metal parts required engine lathes. The principle was ancient. Mount a piece of metal between 2 centers, spin the metal, hold a cutting tool against the spinning surface. The tool removes material. The metal becomes round, becomes smooth, becomes precise. Industrial lathes scaled this principle to massive proportions. A typical engine lathe in 1900 measured 12 feet long. The bed was cast iron weighing 2 tons. The headstock contained gears and a spindle driven by leather belts from overhead shafts or dedicated motors. The lathe could spin work ranging from 1 inch to 24 inches in diameter. Speeds ranged from 50 revolutions per minute for large heavy work to 2,000 revolutions per minute for small diameter finishing cuts. The lathe had no guards. Guards would prevent the machinist from accessing the work. The spinning metal was completely exposed. You stood 18 inches from rotating steel all day. You reached past it. You measured it while it spun. You leaned over it to check the finish. The lathe assumed you would stay clear. It assumed you would never make a mistake. The danger of the lathe was rotational entanglement. Any loose item that touched the spinning work would wrap around it. This included clothing, hair, rags, measuring tools, and human limbs. The physics were unforgiving. A shaft spinning at 300 revolutions per minute completed 5 rotations every second. If fabric caught on the work, it would complete 1 full wrap in 1/5 of a second. A human arm is approximately 30 inches in circumference. At 5 rotations per second, an arm would be fully wrapped in less than 2 seconds. The wrapping did not stop when the arm was wound tight. The rotation continued. The body followed. The machinist was pulled into the machine and wound around the work like thread on a spool. The lathe did not recognize the difference between fabric and flesh. It simply continued spinning until someone stopped the motor. Entanglement happened in multiple ways. The most common was sleeve contact. Machinists wore long-sleeve shirts. The sleeves were supposed to be tight at the wrist with buttons fastened, but shops were hot. Metal cutting generated tremendous heat. Machinists would roll up their sleeves or leave cuffs unbuttoned. A loose cuff would hang perhaps 2 inches from the wrist. That was enough. The machinist would reach across the spinning work to adjust the cutting tool or to measure the diameter. The cuff would brush the work. The work grabbed. The sleeve wound. The arm followed. By the time the machinist realized what was happening, their arm was already wrapped twice around the spinning shaft. Pulling back was impossible. The rotation was too fast. The grip was too tight. The machinist could only scream and hope someone reached the motor control before their entire body was wound into the machine. The second common entanglement was hair. Women did not typically work as machinists, but they did work in factories with lathes. Women operating lathes in munitions plants during World War I were killed by hair entanglement at horrifying rates. Long hair was required to be pinned up, but pins came loose during a 10-hour shift. A single strand of hair touching the spinning work was enough. The work grabbed the hair. The scalp followed. If the woman was fortunate, she was merely scalped. If she was unfortunate, her entire head was pulled into the lathe, and her neck broke when her skull struck the tool post. In 1917, a munitions plant in Pennsylvania reported 6 deaths from lathe entanglement in a single month. All were women. 5 involved hair. 1 involved a scarf that the woman was wearing despite regulations prohibiting loose clothing. The factory implemented mandatory hair nets. Deaths from hair entanglement dropped to 0. Deaths from sleeve entanglement continued. The third type of entanglement was rags. Machinists used cloth rags to wipe oil from work and to clean metal shavings from the lathe bed. The safe procedure was to stop the lathe before wiping. That took time. Stopping and starting the lathe repeatedly reduced productivity. Experienced machinists learned to wipe the work while it was spinning. They would hold the rag loosely so that if it caught, they could release it before their hand was pulled in. This worked most of the time. Sometimes the rag caught and wound before the machinist could let go. The rag wrapped around the work in a fraction of a second. The machinist's hand was still holding the rag. The hand wrapped with it. In 1913, a machinist in Detroit lost his hand this way. He was wiping a spinning shaft. The rag caught. He tried to release it. His fingers were already tangled in the fabric. His hand wrapped around the shaft. The bones broke. The tissue compressed. When the lathe finally stopped, his hand was flattened against the shaft to a thickness of 1 inch. Surgeons amputated at the wrist. Lathe entanglement was distinct from other industrial accidents because of the winding mechanism. A circular saw would cut. A planer would crush. A lathe would wind. The human body wrapped around the spinning work like rope on a drum. This created injuries that were difficult to categorize. The body was not severed. It was not crushed in the traditional sense. It was twisted and compressed simultaneously. Bones broke in spiral patterns. Tissue was sheared by rotational forces. Blood vessels were torn by torsion. Surgeons who treated lathe accident victims described the injuries as among the worst they encountered. The damage was distributed throughout the body. There was no single point of impact to repair. The entire structure had been twisted beyond the limits of human anatomy. The speed of the lathe determined survival chances. A large diameter shaft spinning at 50 revolutions per minute was slow enough that an entangled worker might survive if the motor was stopped quickly. The wrapping happened slowly enough that bystanders had time to react, but most lathes did not spin large work at slow speeds. Most work was smaller diameter running at higher speeds. 300 to 1,000 revolutions per minute was common. At these speeds, entanglement was effectively instant death. The worker would be wound around the work in less than 3 seconds. By the time anyone reacted, the worker was already fully entangled. Stopping the motor at that point simply meant the body stopped spinning. The damage was already complete. The lathe had no emergency stop at the machine itself. The motor was typically located elsewhere in the shop or in a basement machinery room. The lathe was powered by leather belts running from overhead shafts or by direct motor drive with controls mounted remotely. If entanglement occurred, someone had to run to the motor controls and shut down power. This took time. 15 seconds was optimistic. 30 seconds was more realistic. In that time, a lathe spinning at 300 revolutions per minute would complete 150 rotations. A human body would wrap around the work 150 times if there was enough body to wrap. There was not. After perhaps 20 rotations, the body was compressed so tightly against the work that further wrapping was impossible. The body simply ground against itself and the machine. Witnesses described hearing the impacts, a wet thumping sound as the compressed body struck the tool post on every rotation. Experienced machinists died more frequently than beginners on lathes. This pattern matched the planer table deaths. Beginners were cautious. They stopped the lathe before reaching near the work. They kept their clothing tight and their hands clear. They survived. Machinists with 5 or 10 years of experience became efficient. They learned to work with the lathe spinning. They would measure work while it turned. They would adjust tools without stopping rotation. They would wipe oil with the work at full speed. This saved time. It increased productivity. It also meant they were placing their hands near spinning metal dozens of times per hour. Eventually their timing was off. Eventually their sleeve was loose. Eventually the work grabbed them. Factory accident statistics from the 1910s show that 75% of lathe entanglement deaths involved machinists with more than 5 years of experience. The machine did not kill the careless, it killed the confident. Some machinists tried to protect themselves after seeing entanglement accidents. They would cut their sleeves short or wear sleeveless shirts despite dress codes. Foremen would send them home to change. Proper attire was required. The proper attire included long sleeves. The long sleeves killed them. Other machinists tried working with their arms extended, keeping their body as far from the spinning work as possible. This created awkward postures that caused fatigue. Fatigue led to mistakes. Mistakes led to entanglement. A few progressive shops allowed machinists to wear tight-fitting coveralls instead of standard shirts and trousers. This reduced entanglement risk. It also marked the machinists as being concerned about safety, which other workers interpreted as cowardice. Social pressure drove many machinists back to standard loose clothing. They chose social acceptance over survival. The lathe did not care about social dynamics. The lathe just spun. Factory owners knew lathes were killing workers. The accident reports were consistent. Machine shop insurance policies in 1910 listed lathe entanglement as a standard expected loss. Insurance actuaries calculated that a shop with 20 lathes would lose 1 worker every 3 years to entanglement. This was considered normal. Some shops tried implementing rules requiring workers to stop lathes before reaching the work. This reduced productivity by approximately 15%. The shops abandoned the rules after 1 month. Productivity mattered more than hands. Other shops tried installing foot-operated emergency stops at each lathe. This worked if the worker's foot was still free to reach the pedal. If the worker was already wrapped around the work, their feet were off the ground. They could not reach the pedal. The emergency stop was useless. The engineering community proposed solutions. In 1912, a machinist-turned-inventor developed a clutch system that would disengage the lathe spindle if resistance suddenly increased. The theory was that an entangled body would create enough resistance to trigger the clutch. Testing showed the system worked inconsistently. Sometimes it triggered, sometimes it did not. Sometimes it triggered during normal heavy cutting and stopped the lathe unnecessarily. Shops that installed the system removed it within months. False stops were too disruptive. Another inventor proposed proximity sensors that would stop the lathe if a human body came too close to the spinning work. The sensor technology in 1912 was not sophisticated enough to distinguish between a machinist's body and the legitimate presence of hands during normal operation. The system stopped the lathe constantly. It was abandoned. The psychological danger of the lathe was the familiarity. A machinist would work at the same lathe for years. They would spin the same types of work at the same speeds hundreds of times. The lathe became familiar. Familiar became safe. The machinist would lean closer. They would reach across the work more casually. They would wipe the spinning metal without thinking. Then one day the rag caught differently. Or their sleeve was looser than usual. Or they were tired and their reaction time was slow. The work grabbed. The wrapping began. In that moment, the familiar machine became alien. The tool they had worked with for years was now killing them. They had perhaps 2 seconds of consciousness before the compression broke ribs and collapsed lungs. In those 2 seconds, they understood that their experience meant nothing. The lathe did not respect familiarity. The lathe respected only physics. Some workers survived entanglement with permanent injuries. A machinist who lost an arm to wrapping could sometimes return to work operating lathes one-handed. A machinist who lost fingers could sometimes continue working with modified tools. But most entanglement victims did not survive. The wrapping was too severe. The compression was too complete. The time between entanglement and motor shutdown was too long. In 1915, the National Safety Council reviewed lathe accident data from machine shops across 15 states. They found that 92% of lathe entanglement accidents resulted in death. This was higher than almost any other industrial accident type. Circular saws had a 60% fatality rate. Planners had a 70% rate. Lathes had a 92% rate. Once the work grabbed you, you were almost certainly dead. The deaths followed patterns that insurance companies tracked with actuarial precision. Monday mornings saw fewer entanglement accidents. Workers were rested and cautious after a day off. Friday afternoons saw the highest accident rates. Workers were fatigued after 5 days of 10-hour shifts. Their attention wandered, their clothing was loosened from the heat, their reaction times were slower. The lathe did not care what day it was. The lathe spun at the same speed on Monday and Friday. But tired workers on Friday made different decisions than rested workers on Monday. Those decisions determined who went home and who was carried out wrapped around a steel shaft. Some machine shops developed informal warning systems. Senior machinists would watch younger workers and shout warnings when they saw loose clothing or careless positioning near spinning work. This worked only in quiet shops. Most shops were not quiet. The sound of multiple lathes running, overhead belts turning, and metal being cut drowned out shouted warnings. A machinist leaning into danger could not hear the warning. They would not know they were about to die until the work grabbed them. Other shops tried buddy systems where machinists worked in pairs and watched each other. This reduced accidents slightly. It also reduced productivity because one machinist was watching instead of working. The shops abandoned the buddy system. Cost mattered more than lives. The lathe era did not end because of safety improvements. It ended because of technology. Turret lathes and automatic screw machines became common in the 1920s. These machines enclosed much of the spinning work behind guards. The machinist loaded parts and set tools but did not stand next to exposed spinning metal for hours. Entanglement rates dropped dramatically. By the 1940s, most production machining had moved to semi-automatic equipment. The old engine lathes remained in use for custom work and repair jobs, but their dominance was over. The great manual lathes were eventually scrapped or relegated to small shops that could not afford newer equipment. The machinists, who had spent decades standing 18 inches from spinning steel, simply moved to other machines. The shops found new ways to injure people, but nothing matched the lathe for the efficiency of its killing. The total death toll from lathe entanglement in American machine shops is difficult to calculate precisely. Accident records are incomplete. Many shops did not report deaths to authorities. Many deaths were attributed to machinery accidents in general rather than to lathes specifically. But estimates from machinist union records and industrial safety reports suggest that between 1890 and 1940, lathes killed at least 1,200 workers through entanglement in the United States alone. This does not include workers who lost limbs but survived. This does not include workers who died from infections after partial entanglement and amputation. These are immediate deaths from being wound around spinning work. That is 2 machinists every month for 50 years. Most were men between 25 and 45 years old. Most had families. Most had more than 5 years of experience. They were skilled workers. They understood the machines. They knew the dangers. They believed their experience protected them. For 50 years, the engine lathe was the heart of American manufacturing. Every machine shop had them. Every machinist worked them. The lathe spun metal at speeds ranging from 50 to 2,000 revolutions per minute, 5 rotations per second at the low end, 33 rotations per second at the high end. The work was exposed. No guards, no barriers, just spinning steel and the assumption that you would keep your clothing tight and your hands clear. You stood 18 inches from the rotating work all day. You leaned over it to check dimensions. You reached past it to adjust tools. You wiped it clean while it spun because stopping and starting wasted time. The lathe tolerated this for hours, for days, for years. Then one day your sleeve was loose. Your attention wandered. Your hand was too close. The work grabbed. The sleeve wound. The arm followed. In 2 seconds, you were wrapped around the spinning shaft like thread on a spool. In 3 seconds, your shoulder was dislocated. In 4 seconds, your ribs were broken. Someone ran for the motor control. 30 seconds later, the lathe stopped. What unwound from the shaft was no longer a machinist. It was no longer a person. It was simply what remained after rotational physics had treated a human body like thread. The lathe did not apologize. The lathe did not malfunction. The lathe simply spun. 5 times per second. Too fast to release. Too powerful to escape. Winding everything that touched it until someone stopped the motor or there was nothing left to wind.